Hello advanced algebra students, welcome back to another video lesson as we take a look at trying to test if two functions are inverses of one another. It's kind of the third component to inverses that we will be working with. Before we get there, why don't you try this warm-up question for me, please? All right, so as yesterday's skill, how do we convert equations into the inverse? Remember the first thing to keep in mind, I guess, is that g of x really represents y, and then we switch the x and y around. X equals 1/2 y plus 2, and then we're going to solve this equation for y, which means I got to move the 2 first. I'm going to carry my work over here. X minus 2 equals 1/2 y, and to get rid of 1/2, we actually multiply both sides by 2. And that's where we got to be careful on this side. Multiplying by 2 gives me 2x minus 4 equals y. But then we're going to change that y value to show that we really found the inverse of that g function. All right, so there's the inverse of 1/2 x plus 2. Now that's that second skill, converting the equations into the inverse. We also learned how to take graphs or how to take ordered pairs and find their inverse. And today we jump into this third skill. I'll get to that in a moment. Here's the target practice answers from yesterday. I just wanted to make sure that I shared them with you so that you had a little bit of feedback. Another way to write f of g of x is this way, f o g, and then the x value, and then those were the answers. All right, now, the third thing we need to do with inverses is we need to try and figure out if I can just take a look at these two, f of x and g of x, and how can I figure out if they are inverses of one another? And it comes in two parts. We must show that f of g of x and that g of f of x, that when we do both of those, we get a value of x. That's the only way we can tell, right? And that's what we're going to do here. So f of g of x, we're going to take this and plug it in to the f function, or 2 times 1/2 x minus 7/2. Okay, so we put that in there, plus this 7. And then we're going to see what that equals. 2 times 1/2 x is x. 2 times negative 7/2 is negative 7. And then we've got this plus 7, where negative 7 plus 7 is 0. So for this one, we are left with x. That checks out. Now we've got to go the other way. Find the g of f of x. Take this and plug it into that x. Or 1/2 times, what are we plugging in? The 2x plus 7. Minus the 7/2 from that g of x function. Right, this goes back to our composites that we did early on in H-1. 1/2 times 2x is just x, plus 1/2 times 7 is 7/2, and then 7/2 minus 7/2 is 0, so we're just left with x. So both of these, f of g of x and g of f of x, both equal x. Therefore, they are indeed inverses of one another. Why don't you try doing that with this problem? All right. Why don't you see if these two are inverses by using those composites? So again, we're looking first for the f of g of x. So we're plugging in this over here, 5 times 6/5 x plus that 4/5, right? That's the whole g of x function, minus 4 all over 6. We got to figure that out. 5 times 6/5 x is just x, plus 5 times 4/5, that's 4, minus 4, all over 6, x plus 0 over 6, 0. And we're left with x over 6 if we did that correctly. And if we did it correctly, we can kind of stop there and say, nope, they're not inverses of each other because it doesn't equal just the x value. Right? It doesn't equal just the x value. Let's try the next one. I'm going to go back for a moment. I believe I made a mistake. I got to figure out where I made them. I see where. Yes. Okay. Here we go. If we multiply 5 by 6/5 x, we're left with 6x, right? 6x plus 4 minus 4, or 6x plus 0 over 6, and 6x over 6 is indeed equal to x. Okay, I multiplied this part wrong right there. So it does equal x. Now let's find the g of f of x. Plugging in the f function into the g. 6/5 times 5x minus 4 over 6 plus 4/5. When we distribute this, okay, this 6 is going to cancel that 6, and we have 5x over 5 minus 4 over 5 plus 4 over 5. These two cancel each other out. 5x over 5 is indeed just x, so they are indeed inverse functions of each other. All right, let's try another one. See what you get for number 3. Let's take a look at f of g of x. Okay, the f of g of x. Plug the g of x into there. So 4 times x minus 2 all over 4 plus 2. 4 out front times something over 4 will cancel those two 4s, and x minus 2 plus 2 is equal to x. Now we've got to try and do it the other way. G of f of x. Take the f function and plug it into there. So 4x plus 2 goes into that. Then we got to write minus 2 all over 4. 2 minus 2, those are going to cancel, or we have 4x over 4, which is x. And so, yes, they are inverses of one another because both of their composites are equal to x. Last one. So, again, we got to start by finding the f of g of x. So this is going to go in that x. X to the 5/2. But that number, right? That number, we only put it in for x. We still got to keep that 2/5. And what we learned earlier in the year, power to a power, I multiply, and I get x to the 10 over 10, which is x to the first, or just x. If I try it the other way around, where I'm plugging the f function into the g, we get x to the 2/5 raised to the power of 5/2. This again is going to be 10/10, or x to the power of 10 over 10, which is just 1, or just x. So they are indeed inverses of each other. And it's all about using those composite functions to plug it into the other equation, but we do have to make sure we do it and check both ways. This is what we'll be looking for on the mini test in terms of showing your work. So if you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.